Hello students, welcome back to your class on file system. Last class we had discussed about your file mounting, file sharing and file protection. And we had also started the discussion about your file system implementation where we saw a layered file system structure. So as a part of your layered file system structure, it was the structure that was required to be present on the hard disk in order to implement the file system. Now, we will discuss what is the data structure that is required to be present in the memory. Memory, I mean the main memory. So, what is the data structure that is required to be present in the main memory to implement the file system? So the next concept that we have is in-memory file system structure. So in-memory file system structure are used for file system management as well as performance improvement via caching. And there are various data structures and there are various tables that is maintained. We can see it listed here. So the first one we have is the in-memory mount table that contains a list of all devices which is being mounted, and whenever the connection is maintained to a device, an entry will be done in the mount table. The next one we have is the in-memory directory structure. So this contains a list of directories which is recently accessed by the CPU. The directories present in the list can also be accessed in the near future, so it is better to be maintained in a temporary storage like in cache. The next one we have is the system-wide open table. So this contains a list of all open files in the system at a particular point of time. Whenever the user opens any file for reading or writing, the entry will be made in the open file table. I think we had discussed previously also about the system-wide open file table and per process open file table when we had discussed about the operations. So the other one we have is the per process open file table. So this contains the open file subjected to every process. So whichever file a particular process is opened, so those files shall be maintained here. But since the system-wide table already have all the files that is opened in the system, the per process table contains a pointer to the system-wide open file table. So having seen the data structure and the tables used, now let us see the illustration of the same. So here, and apart from the tables that we discussed, there is also a buffer that is maintained. So the buffer holds the file system blocks whenever they are being read from the disk and it is written to the disk. So why is this buffer used? We know the speed of the CPU, main memory and your disk is varied. So the reading and the writing on the disk takes a little longer time, so the data will be put in the buffer. And if you just go check the system calls that is available for read and write also, you can see one of the argument that is passed would be your buffer. Now let us discuss what are the steps that is required to create a file, open a file, read a file and write a file. So last class we had seen the layered file system structure, where we had seen the logical file system and the file control block. So all that will be intact here again. So for creating a file, if you remember, we had that layered structure where it starts with the application program. So the application program is going to call the logical file system. So the logical file system is which is one that knows the format of the directory structure. Now then the logical file system is going to allocate a new FCB, that is your file control block. If all FCBs are created at the file system creation time, an FCB is allocated from the free list. So FCB can be created in two ways. You can have FCBs all created in a pool, and whenever there is a new file created, it can go allocating an FCB, or whenever a new file is created, an FCB also can be created eventually. Now then the logical file system is then going to read the appropriate directory into the memory, and it is going to update the directory with the file name and the file control block. The directory writes the so here we have the directory structure. So whenever it opens a file, an entry is created in the directory structure. Now it updates the directory structure with the it is, you can see here we have the file control block that is a part of your secondary storage. So it is writing it back to the disk, and if there are any updates, the directory, and then it is going to write the new file name and the file control block. Now the next thing that we have is the illustration about reading a file. So to read a file, it is obvious that there should be an existence of the file in the system. So before we open a file to read, it checks if there is any other process that is already opened the file in the system-wide open file table. If it is, then a per process open file table entry is created pointing to the existing system-wide open file table. So if that is not a case, then probably it is going to open a file, and on the secondary storage it is going to check for the file control block, and this file control block is copied into the system-wide open file table in the memory. This table also tracks the number of processes that have the file open. The next entry is made in the per process open file table with a pointer to the entry in the system-wide open file table. The function then returns a pointer or an index to the appropriate entry in the per process open file table. So in Unix we call this pointer or an index as file descriptor, and in Windows we refer to it as a file handler. So all subsequent file operations shall be done via this handler. There are many commands in Unix where you can be deriving or retrieving the value of the file descriptor, and this pointer or the index shall be attached to the file, and this pointer shall be used as a part of every operation that you perform on the file. Just to repeat it again, so whenever it is going to do the read operation, it is first going to check if some other process is already opened that file in the system wide open file table. If it is, then it just extends it with the per process open file table. If no process has opened it, then it is going to find the file control block of that file, and then it is going to copy that entry to the system wide open file table, and then the entry will be, there will be a pointer that will be extended from per process open file table to system wide open file table, and then there will be a pointer or index that will be pointing to that particular file. So how long will this entry in the per process open file table remain? It will remain until the process closes the file. So once the process runs the close system call, so this entry from the per process table shall be removed. And what about the system wide open file table? I told it to you earlier. There will be a counter that will be maintained, which also keep tracks of number of process that it is using. So now the count of the open will be decremented. So eventually, if all other process that is using the file shall close, then an entry from the system wide open file table also shall be removed. So this is about your data structure or the support that is there in the main memory for the file system to perform the file operations. A small concept that we have is about your partitioning and mounting. So we could consider your hard disk to be divided into multiple partitions, and each partition can span to multiple disks. That is the concept of your RAID. I told it to you earlier also. RAID is something out of the scope of your syllabus, so let us not get into detail there. So let us just consider to the first one, that is your disk can be divided as or can be treated as multiple partitions. So it is the same even with your laptops or your PCs that you have. If you have your hard disk to be of 1 terabyte, that 1 terabyte will be divided into multiple partitions. Now each partition can either be raw or cooked. Now what do we mean by this raw or cooked? We say the partition is raw if it does not contain any file system. We say the partition is cooked if it contains a file system. Now you can observe this raw and cooked. For example, when you buy a new pen drive and for the very first time you insert that pen drive onto your laptop or your PC, you will not be allowed to directly copy the data to it. You can see you will get a pop-up and it will ask you to format your pen drive to a specific file system. Now what is happening there is, your pen drive is raw, it does not contain or it does not follow any file system. You get it to follow to some file system only when you format it to a specific file system. And then we have the boot information that can be stored in a separate partition. Again, it has its own format because at the boot time the system does not have the file system code loaded. Therefore, it cannot interpret the file system format. Now, what is the boot information? It is a sequential series of blocks loaded as an image into the memory. So the execution of the image starts at a predefined location such as the first byte. This bootloader in turn knows about the file system structure to be able to find and load the kernel and start its execution. The root partition, probably when we were discussing about your file mounting, you saw the root and you saw various other directories. So here the root partition would contain the operating system kernel, and sometimes it also contains other file system is mounted at the boot time. So if you remember to the image that we had the triangles of root, user, program and all that. So it is allowing it to be mounted at the boot time. And the other volumes can be automatically mounted at the boot or manually mounted later depending on the operating system. But all that you see now is it would be automatically getting mounted. After the successful mount operation, the operating system verifies that the device contains a valid file system. It is done by asking the device driver to read the device directory and verifying that the directory has the expected format. If the format is invalid, then the partition must have its consistency checked and possibly corrected either with or without the user intervention. Finally, the operating system notes in its in-memory mount table that the file system is mounted along with the type of the file system. The root partition is mounted at the boot time. It contains the operating system kernel and possibly other file system. The other volumes can automatically be mounted at the boot time or manually. So this is about your partition and mounting. The next thing that we have is about your virtual file system. The file system consists of 3 layers as shown in the diagram here. So the first layer is the file system interface based on the open, read, write, close system calls along with the file descriptor, and then the second layer we have is your virtual file system layer. So the virtual file system layer serves two important functions. That is, it separates the file system generic operations from their implementation by defining a clean interface, that is the virtual file system interface. Several implementation for the virtual file system interface may coexist on the same machine, allowing transparent access to different type of file systems that is mounted locally. The second thing is, it also provides a mechanism for uniquely representing a file throughout the network. The virtual file system is based on the file representation structure called as the vnode. So vnode is a numerical value that will be unique network wide. So previously when we were discussing about your file operations, so we told in the file system every file shall be identified by a unique number. Here again in the virtual file system, it also helps us to identify a file uniquely network wide using the vnode number. So the kernel maintains one vnode structure for each active node. So when I say it is a network, there can be multiple nodes. Nodes are nothing but your systems. So there will be a vnode structure that will be maintained for every node. The virtual file system distinguishes the local file from the remote file, and the local file are further distinguished from their file system type. If there is a system that follows multiple file system, so the virtual file system also helps us to distinguish the file based on its file system. So that is about your file system structure and the file system implementation in the hard disk, in the memory, and about your file system implementation. The next thing that we have is about the directory implementation. So the directory implementation can be having two approaches. One is the linear list and other one is list indexing using the hash table. So the selection of the directory allocation and the directory management algorithm significantly affects the efficiency, performance, and reliability of the file system. So let us look into detail about both the approaches, what are the advantages and disadvantages associated with these approaches. So the first approach that we have is the linear list. So linear list consists of a list of file names that has a pointer to the data block. Now, how does the creation of a new file happen in case of your linear list directory implementation? It is going to first search the directory to make sure that no file exists with the same name. So if there is no file existing with the same name, then a new entry is added at the end of the directory. The next thing, to delete a file, again it has to search the directory for the named file, and then it is going to release the space allocated to that file. In the creation and the deletion, I am emphasizing on the search. So now once the deletion is done, how do we reuse that directory entry? So we could be doing it in 3 ways. One is to mark the entry as unused. The second method is to attach the entry to the list of free directory entries. The last method is to copy the last entry in the directory into a freed location and to decrease the length of the directory. So once the deletion is done, the free space or the directory entry could be reused using these methods. When I discussed about the creation and deletion, I told I am emphasizing on the search. Either you create a new file, you are searching through the linear list. Either you delete a file, you are again searching through the linear list. So the problem here is finding a file requires linear search, which is slow to execute. So one of the solutions that we could have is to cache most recently used directory information, or to sort the list, and we could be having a binary search which could decrease our search time. So the advantage in this case, yes, it is simple to implement, but at the same time the disadvantage is it is time consuming. So the second approach that we have is the hash table, or indexing is what we call. So what do we do here? The linear list of file names that is stored in the directory entry is given an additional data structure, that is the hash table. So we use the hash function. So now what does the hash table contain? It takes the value that is computed from the file name. So every file name, there shall be hash function that is applied, which returns a value. Now this value is stored in the hash table, and it also returns a pointer to the file name in the linear list. So why is this done? So this indexing is definitely going to reduce the search time at a very great extent, and insertion and deletion to the directory structure is very easy. But there are some disadvantages that is also associated with the hash table implementation. That is, what if there is a collision? What if there is a situation in which two file names hash to the same location? So there should be some provision or mechanism that is made to resolve the collision. And the other disadvantage could be the fixed size of the hash table and the dependence of the hash function on the size. So these are some of the issues that is associated with the indexing implementation of the directory. So we have these two approaches for the directory implementation. The next thing that we have is about the allocation method. So now what is it with the allocation? We talk about the disk space utilization. Now when I say disk and hard disk, so hard disk, the access method that is followed in the hard disk is a direct access. So this allows us the flexibility in implementation of the files. In most cases, many files are stored on the same disk. Now, having said that, how do I allocate the space to the file so that the disk space is used effectively and the file access is also made quick? So there are three allocation methods: contiguous allocation, linked allocation, and indexed allocation. We will see each of the allocation methods in detail. So the first method we have is the contiguous allocation. Here it requires that each file occupy a set of contiguous blocks on the disk. Accessing a file is very easy because it only needs the starting location and the length of blocks. So contiguous allocation of a file is defined by the disk address and the length of the first block. If I say the file is using n blocks long and starts with the location B, then it occupies B, B plus 1, B plus 2, B plus 3, so on up to B plus n minus 1. The directory entry for each file indicates the starting address and the length of the area allocated for this file. For example, you have the file name count, so it is starting at the block number 0 and its length is 2, so it is occupying the block 0 and 1. You have a file name mail, so it is starting at 19 and it needs 6 blocks, so 19, 20, 21, 22, 23, 24. So this is how is the contiguous allocation happens, and this is the directory structure of the contiguous allocation. Accessing a file that has been allocated continuously is very easy. We can have sequential access, or we could be doing even a direct access. So in case of sequential access, the file system remembers the disk address of the last block that is referenced when necessary and it reads the next block. In case of direct access, if it wants to access a block, say I of the file that starts at the block B, we can immediately access the block B plus I. Thus, thereby we can be having sequential as well as direct access in case of contiguous allocation of disk space. But we can see that there are a lot of disadvantages that is associated with this method. So some of it is finding a space for a new file is difficult. The system chosen to manage free space determines how this task is accomplished. Any management system can be used, but they are all very slow in finding. And another disadvantage is satisfying a request of size n from a list of free holes is a problem. It could follow one of the algorithms that we have discussed earlier, that is your first fit or best fit is some of the common algorithms that it might use. Any of the algorithm that it uses, as we already know, it suffers from external fragmentation. As the files are located and deleted, the free disk space is broken into pieces, and external fragmentation exists whenever free space is broken into chunks. It becomes a problem when the largest contiguous chunk is insufficient for a request. Storage is fragmented into number of holes, none of which is large enough to store a particular data or a file. So another solution to this particular problem would be the extended based system, which is an extension to the contiguous allocation. So to minimize this issue of fragmentation, so what we could do here is a contiguous chunk of space would be allocated initially, and then an amount that is extended. So there will be another chunk of contiguous space that is allocated, which will be called as an extend. So there will be two chunks that is allocated to the same file. This could reduce some amount of the issue that we had of finding a contiguous space that is sufficient to allocate a single file or a data unit. So that is about your contiguous allocation method on your disk system.